Alrighty, in today's video, we're going to be doing 1.7 rational expressions. A rational expression can be written in the form of P divided by Q, where Q cannot equal zero, right? If it equals zero, it's undefined. So a rational expression or a rational function or anything like that, just a fancy way of just simply saying a fraction type of problem. All right, so I will say as a pre-warning, I'm going to be going over some things. And then on your homework, it's actually a lot easier. So I'm actually going to go more in depth just because you need to know the content. But the homework is not going to be as difficult as what we're about to see. All right, so for the first set, we're going to be on number one. We're going to look on page 73. We're going to look at number one. So we have 2x squared plus 7x plus 3 divided by x squared minus 2x minus 15. I'll show you kind of what the homework is going to look like, and then I'll go into more of a further details here. So what we're going to start off is I have this usually in 3 steps. Step 1, you will factor everything. Step 2, you will cancel things that are in common. And step 3, just simply write what's left. All right, so factor, cancel, write. All right, to start off, the homework is going to tell you simply what can X not be, right? What's the restriction to the domain here? So what you do is you just have to simply just factor the denominator. So I now, from the last video, know a trinomial will factor into 2 binomials where the leading term is an X. And then I have to figure out what multiplies to negative 15 and adds to negative 2. So if I do my little chart here, multiply to negative 15, which is what the C is, and then add to my B, which is negative 2. So I go 115, 3, 5. Since it's a negative, I know one of these has to be a negative, and since that I'm adding to a negative, that tells me the bigger number has to be negative. That gives me negative 14, and that gives me negative 2, so there's my winner. So I get plus 3 and negative 5. Now, for your restrictions, you just have to use that zero product rule. And you're going to take the factors you just came up with, the x plus 3 equals 0, and the x minus 5 equals 0, and you're going to solve for x. So this would be x equals negative 3, and this would be x equals 5. This is what x cannot be. And that's all you have to do on the homework for the beginning of it. Through the middle of it, it's going to finish this question off. So then you would have to factor this. So I know that a trinomial factors into 2 binomials where the leading term will be an x. I'll do this in a different color. And then I'm going to do my restriction. So I need to multiply to a times c. So since there's an a, I need to do 2 times 3, which gives me 6. And then I'll still add to my b, which is 7. So I do 1 and 6, 2 and 3. Since it's a positive and I'm adding to a positive, I know both of them will be a positive. And that gives me 7 and 5. So I see that that is my answer. So I get plus 1 plus 6. But then since I have a leading coefficient of something other than 1, I just simply have to divide. So anything left in the denominator becomes the coefficient. So that becomes 2x plus 1. And then 6 divided by 2 is 3. So if it simplifies nicely, there is no coefficient for that one. Now, I rewrote this completely, but what I probably would have done is probably just drew a line here and wrote the actual work just to save some steps, but you can do it however you need to process. All right, so I have officially factored everything. Step 2 is to cancel anything in common. So I see there's an x plus 3 and an x plus 3. I see nothing else in common, so now I'm going to write what's left. So our ultimate answer here is 2x plus 1 over x minus 5. Now, caution here, if you do all this work and then find the restrictions on what's left, you'll miss one of those values. So you want to do your restrictions at the very beginning before you cancel. All right, let's definitely do a lot more. Let's look at number 2. Number 2 says x squared plus 5x minus 6 divided by x cubed plus 2x squared minus 3x. Again, I'm going to factor. So when I look at this one, I see that I have a x in common. And then if I take an x out of all this as my greatest common factor, I'll have x squared plus 2x minus 3. So you can kind of see that I took one x from each side and from each term. And then I'm just going to rewrite this so it's all together, but you really could skip some steps here. All right, so now I'm going to do the AC method, or the T-chart method, or however you want to call it. I know a trinomial factors into two binomials. Same concept here, where the leading term will be an x. And since the leading coefficient for both of these is 1, all I got to do is figure out what multiplies to my C and adds to my B. So in this top one, two things that multiply to 6. But add to 5, I would go 1, 6, 2, 3. I'm multiplying to get a negative, but I added to a positive, so that tells me a smaller number has to be negative. That gives me 5 and 1. So there's my winner there. So minus 1, positive 6. The next one was need to multiply to negative 3, add to 2. So that's going to be 1 and 3. I multiplied to a negative, so adding to a positive. So that tells me the smaller one's going to be negative, which gives me 2. So I see that negative 1 and 3, positive 3. All right, so again, when dealing with restrictions, before I cancel, I'm going to set the denominators equal to 0. So x equals 0 is 1, x minus 1 equals 0, and x plus 3 equals 0. So there is 3 factors here, right? X minus 1, and x plus 3. Well, that one's already done. This would be x equals 1, and this will be x equals negative 3. So x cannot be negative 3, 0, and 1. Now that I got my restrictions out of the way, I can move on to step 2, and I will cancel what's in common. So I see an x minus 1 on both, and then I will write what's left. So that'd be x plus 6 over x times x plus 3. Now, this is correct. Your book might also go ahead and distribute this out. So it'll be x plus 6 over x squared plus 3x, but it might also accept this as well. I do have it in a sense that if you do write it like this, it should still accept your answer as long as everything is right without having to move on to that next step. But these will be a great example, like if that's what you wrote as your answer and it marked it wrong, then you can argue your case there. All right, let's look at number 4. So we have x squared minus 4x plus 4 over x squared minus 4. So I start off by factoring. So a trinomial factors into two binomials with a leading term of x. What multiplies to 4 and adds negative 4 would be negative 2 and negative 2. So if you need to write it out, so 4, negative 4, you got 1 and 4 and 2 and 2. Since I'm adding to a negative and multiplying to a positive, that tells me both of them have to be negative. So that's negative 5 and that's negative 4. So there's my winners. This right here, hopefully you're seeing this as a special case. This is a difference of squares, which still breaks up into two binomials where the leading term for both is an x, and then you have a 2 for both. So that's going to be a positive and a negative. All right. After this point, I have now got it all factored. So now I'm going to write out my restrictions. In this case, that's x plus 2 equals 0 and x minus 2 equals 0. So I have x equals negative 2 and x equals 2. So x cannot be negative 2 and 2. All right, now that I got my restrictions taken care of, I can cancel what they have in common. Notice I can only cancel one of them because I only had one on the bottom. So when I write what's left, I get x minus 2 over x plus 2. All right. All right, so then the next part of this gets into addition and subtraction. So let's go over that. So I got x minus 3, x plus 5, plus x squared plus 3x plus 2 over x minus 3. All right. So this is where I do the cross out stuff. I'll cross it out and write the new factors here. But the goal is I'm now adding things, but now I basically have 4 problems within one. So instead of just factoring 2 different polynomials, I'll be factoring 4 different polynomials. But notice this one, and this one are all different. So all I have to do is factor this one right here. So I'm going to draw a line through it. And I'm going to write 2 factors where the leading term is an x. And then I want to ask what multiplies to 2 but adds to 3. So it's going to be plus 1 plus 2. Right? Now, this isn't where I can now cancel. With addition and subtraction, just like regular fractions, the denominators have to be the same. So the easiest thing to really do is you can multiply both sets by denominators, but there are certain ones where we could do something a little easier, but you're still going to be multiplying by the least common denominator, which in this case would be x plus 5 times x minus 3. All right. Oh, sorry, my bad. Got ahead of myself on this part. Is x plus 3 and x minus 3, but I don't have to multiply by both. This one, I just need to multiply by x minus 3. But if I do it to the bottom, I have to do it to the top. Same concept over here. I will multiply this one by x plus 5. But if I do it to the bottom, I have to do it to the top. Alrighty, so here we go. So then when I get this part, I'll have x minus 3. Ooh. Technically, this is x minus 3 squared. This will all be over one fraction. So x minus 3, x plus 5. So again, in this, when you're adding, the denominators never change. So I can bring that down and do the actual operation on top. So this would be x plus 1 times x plus 2 times x plus 5. Now here is the issue. I went ahead and factored this because I assumed maybe I might be able to cancel anything. That doesn't always happen. So it might be easier to keep it in its original form because I'm going to have to multiply all this and then combine like terms. So I'm going to do a little bit of cleanup. I'm going to say that this right here is just x minus 3 times x minus 3. So I can fold that out. And I'm going to say this right here is actually x squared plus 3x plus 2. So I can actually multiply it by x plus 5. All right, so let's get through this. So if you remember the special squares, you square the first term when it's a difference of squares. No, so not difference of squares, a perfect square trinomial. That's what it was called. Then x times -3 would be -3, and then -3 times x is -3x, and then you multiply that by 2. So that'd give me -6x. So -3x plus -3x is -6x, and -3 times -3 is a +9, plus all of this. So x squared times x is x cubed. X squared times 5 is 5x squared. 3x times x is 3x squared. 3x times 5 is 15x. 2 times x would be 2x, and 2 times 5 would be 10. All divided by x minus 3 times x plus 5. I would just leave this the same. Combine like terms, so keep yourself organized. There's an x cubed right there. X squared plus 5x squared is 6, plus 3x squared is 9, so that'd be plus 9x squared. -6x plus 15x is now 9x, plus 2x gives me 11x, and then 9 plus 10 gives me 19. So with addition and subtraction, it's probably the hardest just because you have to do some multiplication and simplification. All right, let's definitely do some more of those to make sure we got that down. Let's look at number 14. So we have x squared minus 1, x minus 2, x minus 1, x plus 1. So instead of me starting off with factoring, I think I'm going to go straight into taking the binomials and multiplying them out. All right, so I know the denominator will stay as x plus 1 times x minus 2, and then I'll work this. So x times x squared is x cubed minus x plus x squared minus 1. I'm not worried about putting this in order until my final answer. This I'm going to be cautious with, so I'm actually going to put a minus and then open a set of parentheses so I remember to go back and change all those signs. So that's going to be x squared minus 2x minus 1x plus 2. And so now when I go back, just like we did in the previous sections, I'm going to make this a plus sign and I'm going to change all the signs. All right. So then I can say, all right, x cubed is just x cubed. X squared plus negative x squared would actually cancel the x squares out. And then I have a negative x plus a 2x, so that'd give me 1x, plus another x, so that'd give me 2x. So basically, these would cancel out. And then I have negative 1 minus 2, which will give me negative 3. And then I'd keep this as is. All right. So kind of help organize your information, and you're basically utilizing everything we learned in the previous sections. All right, let's look at number 17. 17 is x squared plus 1 over x minus 3 plus x minus 5 over x plus 3. Again, I'm going to go straight into just figuring out what my denominator is going to be. So that's x plus 3. And this would be x minus 3. All right, so that means I need to multiply this by x plus 3. And I would need to multiply this by x minus 3. So I know the denominator is just going to be x plus 3 times x minus 3. Do your foiling. So this is x times x squared, which is x cubed plus x plus 3x squared plus 3. And then this would be the same concept over here, plus x squared minus 3x minus 5x plus 15. Combine like terms, so I have x cubed plus 4x squared and then that'd be 1 minus 8, so that'd be minus 7x. And then that'd be 18, 3 plus 15. Again, just leave that as is. All right. So let's do another one just to make sure we fully have this down. Let's look at number 19. Let's look at x squared plus 2x minus 35 divided by x minus 5 plus x minus 4 over x plus 3. So again, I'm going to just multiply this by x plus 3. And then I'll multiply this by x minus 5. So I get x plus 3, x minus 5. So I distribute. So I get x cubed plus 2x squared minus 35x plus 3x squared plus 6x minus 105. And then again, distribute this. So this would be plus x squared minus 5x minus 4x plus 20. Combine like terms. I got an x cubed, 2x squared, 5x squared, 6x squared, negative 35 negative 29, negative 30. Nope, I lied. So, okay, so we had negative 35, negative 29, negative 34, negative 38. X. Negative 105 plus 20 would be negative 85. And obviously leave the bottom as is. So it'd be x plus 3, x minus 5. All right, so this is actually a special case. This right here can actually be factored, and really what we should have been doing this entire time is what I did the first time, and we should have tried to factor. So we would have caught it up here. That's why we go through this process here. So turns into an x, two things that multiply negative 35 but add up to 2, 7, 5. So positive 7, negative 5. That gives you negative 35 and adds up to 2. Notice the 5s would cancel. So this is not wrong, but it's not the simplified answer. So this would be the simplified. And so what we're going to do is the minus 5 would actually cancel. So all I would have to do is I wouldn't have to do this part, and I would just have to multiply because it looks more like this. So it looks like x plus 7 over 1, because there's nothing there, plus x minus 4 over x plus 3. So all I have to do is multiply by x plus 3. And that would be it. So this would be x plus 3 on the bottom. That'd give me x squared plus 3x plus 7x plus 21 plus x minus 4. So this gives me x squared 10, 11x, 21 minus 4 plus 17 over x plus 3. This is the answer they want, not this one. Even though we didn't do anything wrong, we just didn't simplify before we went into it. And we did that on the first one and then didn't do it on the rest of them. So that was on me. And really and truly, number 14, x squared minus 1 would have turned into x plus 1, x minus 1. So I couldn't cancel anything out. X squared plus 1 on 17 doesn't cancel or factor at all. And then 19. So let's look at one more. Let's look at number 22. So on 22, this is going to be y squared plus 2 over y plus 3 minus y minus 4 over y minus 3. So in this case, try to factor if you can. Unfortunately, it's unfactorable. So therefore, I can go straight into what I need. And this would be y minus 3. And this would be y plus 3. This time we're going to start checking before diving into something and making it a lot harder than it needed to be. All right, in this example, though, we now see that this is going to be y minus 3 and y plus 3. And then now I can distribute. So y times, go this way, so y cubed plus 2y minus 3y squared minus 6, bring the minus sign, y squared plus 3y minus 4y minus 12. Now, again, this is where I'm going to change this to a plus and then change all the signs inside. And then now I'll combine. So this gives me y cubed. Negative 3y squared minus y squared would give me negative 4y squared. 2y minus 3y is negative 1 plus 4 gives me positive 3. Right? So negative 2, negative 1, positive 3y. And then negative 6 plus 12 just gives me positive 6 over y minus 3y plus 3. All right, so hopefully that made sense with the adding and subtracting. Now we just need to get into our multiplication and division. So let's look at number 23. Let's look at y minus 2 over y plus 1 times y squared minus 1 over y minus 2. This goes back to just a big old fraction. So we're just going to factor each term or each polynomial. So this is good, this is good, this is good, but this one is a difference of squares and would turn into y minus 1 and y plus 1. That's that first step of factor. Step 2 is still the same of cancel things that are in common. When you're multiplying, you can make it look like one gigantic bar. So if there's something over here that can cancel, as long as it's on the denominator on the numerator, you can do that. This is on the numerator, this is on the denominator. And then 3, we just write what's left. So in this case, it is just going to be y minus 1 is my answer. So same process as before, just more of it. So factor, cancel, write what's left. All right, let's look at number 24. 24 is a squared minus 3a minus 4 over a minus 2. When you have a division problem, there's one extra step you got to do before you do what we did. And this is the keep it, change it, flip it. So I'm going to keep the first fraction as is, change this to multiplication, and flip this fraction. Once you've done this step, then repeat the process earlier. Factor, so a trinomial factors into two binomials where the leading term is an a. What multiplies to -4 but adds up to 3? Well, that would be -4 and plus 1. A minus 2 can't go anywhere, so then I'll factor these guys. If y'all need to do the t-chart to organize your information, please do that. So that'd be a, so multiplies to -8 but adds up to -2. That'd be 4 and 2. That'd be a -4, positive 2. All right, so now that I've factored, now I'm going to cancel, and then I'll write what's left. So a plus 1 over a plus 2. All right, let's do another one. So you find addition and subtraction to be the hardest. Multiplication, division is just tedious. So we have 25. So 2x squared minus 5x minus 12 divided by x minus 3 times x squared minus x minus 6 divided by x minus 4. So I'll go straight in. So there's the multiplication, so I don't got to worry about keep, change, flip. It's not division. So I'm going to factor. Now this guy right here factors into two binomials. Leading term is an x. Multiplies to -24, because it's a times c now, and adds to -5. That's 1 and 24, 2 and 12, 3 and 8, 4 and 6. I've got to multiply to a negative, so one of these have to be negative, and since I'm adding to a negative, that tells me the bigger number has to be negative. Well, that gives me -23. That's not right. That's -10. That's not right. That's -5. There's my winner. So this becomes +3 minus 8. Take your a, and you're going to divide them both by a. If you can simplify, great. If you can't, move the denominator as the coefficient. So this now becomes 2x plus 3. This one's just straight up 4, so this becomes x minus 4. So there's my pre-work right there. Do the same thing over here. Trinomials factor into two binomials. The leading term is an x. Multiply to -6, but add to -1. That's going to be 3 and 2, and that'd be a negative and a positive. So now I've factored, now I'm ready to cancel. My x minus 3 goes, my x minus 4 goes, and I'm left with 2x plus 3 times x plus 2. They all are both on the numerator side, and you don't have to worry distributing it. You can just leave it like that. All right, let's do one more like this, and then we'll move on to more complex. So number 27, you have y squared minus 11y plus 24 over y plus 6 divided by y squared plus 5y minus 24 over y plus 6. All right, so I'm going to keep change flip. I'm going to keep change flip when dividing. So this is going to be y squared minus 11y plus 24 over y plus 6 times, I'm going to flip the other fraction. And then now I'm going to factor. So this is y. Two things that multiply 24 but add up to 11. That's got to be 3 and 8. And they'll both be negative. Y plus 6 can't go any further. This would be two binomials. Leading term is y. Multiplies the negative 24 but adds up to 5. Again, that'll be 3 and 8 again, but this time positive and negative that way. And so now I want to cancel what I can. So I can cancel out y minus 3, and I can cancel out y plus 6. So I'm left with y minus 8 over y plus 8. All right. All right, so let's get into more complex rational expressions. So let's look at number 47. All right, so number 47 says 25x to the negative 2 minus 9z to the negative 2 divided by 5z plus 3x over x squared. So this is still a keep it, change it, flip it situation. You would keep the top fraction. This long division bar is your division, so you're going to change that to multiplication, and you'll flip the second fraction. So I get 25x negative 2 minus 9 times z to the negative 2 times, so I'm going to change this part to multiplication, and then I'm going to flip this fraction. So x squared over 5z plus 3x. All righty, so those aren't attached. So what I'm all righty, so here we go. So this has got a mixture of a lot going on. So I'm going to turn these into fractions to get rid of these exponents. So these exponents will now be 25 over x squared minus 9 over z squared times x squared over 5z plus 3x. A good point to note is this entire thing, when I do the cheat, is technically this should be in parentheses because this was part of the grouping. So therefore, this will be part of parentheses while I work on it. So to clean this up, I need to multiply this by z squared, x squared, x squared. So I'd get 25z squared minus 9x squared over x squared z squared times x squared over 5z plus 3x. Good thing we're going over this. All right, so again, this right here has to be in one parentheses because you technically need to subtract this before you multiply for a grouping, and then or PEMDAS or order operations, whatever you want to call it. And then here I'm trying to combine it as one fraction, so now I have it like this. And so then you need to notice that this right here is a difference of squares. So the square root of 25z squared is 5z. 5z minus plus square root of 9x squared is 3x, 3x. And the rest of it is pretty much already factored. So the z squared would cancel. The 5z plus 3x would cancel. So I'd be left with 5z minus 3x over z squared. Just like that. right, so let's do another complex one like that. Let's look at number 48. So this would be 3y over 5 minus 5 over 3y divided by 3 minus 5y. All right, so there's a couple processes here. The way I like to operate is I'll just combine each one of these. So what I'll do is I'll say, all right, if this is 5, I need 3y here, 3y here. If this is 3y, I need 5 here and 5 here. The process of doing that, that gives me 9y squared minus 25 divided by 15y, because the denominator will stay the same. Then I can do the same thing on the bottom here. I just need to multiply this by a y. This is technically by 1, doesn't really do anything. But we'll write it out anyways. So this is then divided by 3y minus 5 over y. So again, I just basically made these two gigantic fractions because now I can apply the keep, change, flip here. That's going to be 9y squared minus 25 over 15y. Change the multiplication, flip the fraction. So I get something like this. And so then I can notice, hey, this right here is a difference of squares again. So that would give me square root of 9y squared is 3y. And square root of 25 is 5. So now when I look at this, I can see 3y minus 5. And then this y would cancel. And so I have right now 3y plus 5 over 15. This can actually go a little bit further, but it's not going to want you to. Actually, it can't because I'm thinking the 3 and the 5. I was thinking, well, 3 can go into 5, 15, but it has to be the same number in both. So it'd be 3 all the way across to 5. So yeah, so that's it. So hopefully that's enough examples to kind of help you through the homework. But as always, if you need more help, please feel free to email me. Other than that, see you in the next video.